In part 6, we discussed two questions. From this question, now we see third example. Find the inverse of following matrices by using transformation method. Here given matrix is elements 0, 1, 2, 1, 2, 3, 3, 1, 1. We have to find inverse of this matrix by using elementary transformation. Now suppose given matrix is A, we have to find its singularity first. So for that we have to calculate its determinant. So we write here in first row plus minus plus. Here element is 0. So skipping first column and first row, we have to find the determinant of keeping this and this. Determinant of 2, 1, 3, 1. That is 2 into 1 is 2, 3 into 1 is 3. So we get in multiple 0. So the first bracket is 0. Now for second. For 1, this element in second column in first row. So we have to find 1, 3, 3, 1 determinant. 1 into 1 is 1. So we write 1 minus 3 into 3 is 9. That is 1 minus 9. 1 minus 9 is minus 8. So minus get plus. 1 into 8 is 8. So we get 8. For these two in first row and in third column. So we have to find determinant of this. 1 into 1 is 1. So we write here 1 minus 2 into 3, 6. In multiple we get plus 2. So 8 minus 10 which is minus 2. In this way we calculate the determinant. Therefore its inverse exists. So we write A into A, inverse is equals to unit matrix. Now substitute the values. Put matrix A here, A inverse, which we have to calculate, identity matrix which is of order 3 by 3. Now we have to reduce this matrix A into unit matrix. For that we have to follow the steps. We have to make entries in the first column as 1, 0, 0, entries in the last column as 1, 0, 0. Then we come to this 1 and then after we make 0 above this 1 and below that 1. Now given matrix is 0, 1, 2, 1, 2, 3, 3, 1, 1. We have to make changes in this way. We have to make the elements in the order 1, 0, 0. So in place of this 0 we require 1. For that 1 is in second row, 0 is in first row. So we interchange these two rows. So for that we have to make elementary transformation as R1 interchange with R2 we get. So we interchange these two rows. First row interchange with second row and second row interchange with first row. That is same elementary transformation in right hand side. So we interchange these two rows. After interchanging we get 1, 2, 3 in first row, 0, 1, 2 in second row. In the right hand side this 1, 0, 0 in second row and 0, 1, 0 in first row. Now we have to change or we have to reduce this 3 to 0. For that we use first row. After multiplying 3 to first row we get 3 into 1 is 3. 3 minus 3 0. So we have to make elementary transformation as R3 minus 3 times R1 we get here 0. We are making changes in third row. So we write first two rows as it is. 1, 2, 3, 0, 1, 2, 1, 2, 3, 0, 1, 2. We are changing third row elements. So we apply the formula R3 minus 3 times R1. So we get 3 minus 3, 0. R3 is 1, R1 is 2, that is 3 into 2 is 6. 1 minus 6, that is minus 5. R3 is 1, R1 is 3. So we get 1 minus 9, that is 8, minus 8. A inverse as it is. Apply the same formula for RHS. R3 is 0 here, R1 is 0, so 0 minus 0 is 0. R3 is 0, R1 is 1, that is 0 minus 3 into 1 is 3, so we get minus 3 for last limit. R3 is 1, 1 minus 0, so we get here 1. In this way, we reduce the elements in first column as 1, 0, 0. Then we require 1 here. Here is already 1. So we have to reduce element above it 0 and element below it 0. For that we apply this two elementary transformation. R1 minus 2 times R2. R1 is 2 here. R2 is 1 here. So we get 2 minus 2, 0. Here we require 0. So for that we apply elementary transformation. R3 plus 5 times R2. R3 is minus 5. R2 is 5. म्हणजेच आपण या ठिकाणी काय करून राहिलो, इथे 1 आल्यानंतर हा 1 ज्या रोमध्ये आहे त्या रोचा रेफरन्स आपण घेऊन राहिलो का. इथे मायनस 2 टाइम्स R2 केलं, इथे प्लस 5 टाइम्स R2 केलं. आपण मायनस किंवा प्लस केव्हा करतो, ज्यावेळेला दोन्ही साईन सारखे असतील त्यावेळेला आपण डिफरन्स घेतो. ज्यावेळेला दोन साईन अपोजिट असेल त्यावेळेला त्याची ॲडिशन घेतो. म्हणजे आपल्याला सेकंड काय करायचं होतं, या ठिकाणी इथे 0 आणायचा होता, त्याच्यानंतर याच्या खाली इथे 0 आणायचा होता. त्यासाठी आपण हे दोन एलिमेंटरी ट्रान्सफॉर्मेशन यूज करू. इथल्या व्हॅल्यू तुम्ही डायरेक्टली 0 लिहू शकता, कारण की हे फॉर्म्युलेज तुम्ही इथे 0 आणायसाठी घेतलेत. त्यानंतरच्या एलिमेंट्स काय येतील तुम्ही या फॉर्म्युलामध्ये सबस्टिट्यूट करून कॅल्क्युलेट करू शकता. सेम फॉर्म्युला तुम्हाला RHS मध्ये यूज करायचा आहे आणि RHS मध्ये यूज केल्यानंतर तुम्हाला ही एलिमेंटरी ट्रान्सफॉर्मेशन अप्लाय केल्यानंतर ह्या व्हॅल्यूज मिळतील. Now after applying this elementary transformation, here we get 2. In place of 2 we required 1. We required here 1. So we have to divide these 2 by 2. So we get 1. So dividing each element of third row by 2. So we write elementary transformation as by 1 by 2 into R3 we get. Keep first row, second row element as it is. In same way, in RHS, keep first row and second row element as it is. Divide each element of third row by 2. So 0.2 is 0, 0.2 is 0, 2.2 is 1. Here also we get 5 by 2 minus 3 by 2, 1 by 2. Now, next our aim is reduce element above the 1 in 0. So in place of 2 we require 0. So here is 1, here is 2. So we have to multiply this third row by 2 or by adding with the elements. Observe the elements. Here by R1 plus R3, R1 is minus 1, here is 1. So minus 1 plus 1, 0. We get here in first row element 0. Here we can take two elementary transformation at a time. For here R2 minus 2 times R3. You can also write R2 minus 2 times R3 in first and then write R1 plus R3, which we already put in properties. That elementary transformation can be changed. We get the same matrix. R1 plus R3. So we get minus 1 plus 1 0 here, 0 plus 0 0 here, 1 plus 0 is 1. So the elements in first row are 1 0 0. For this we have to apply R2 plus 2 times R3. Here R2 plus R3, that is 0 plus 0, we get 0. R2 is 2, R3 is 0. So 1 plus 0 or 1 minus 0 is 1. So we get 1. 2 minus 2 is 0. So we get here 0. Same we have to apply for the RHS. R1 plus R3. R1 plus R3, R1 is minus 2, R3 is 5 by 2, that is 5 by 2 minus 2, which is 5 by 2. Then, 1 by 2. Then R1 plus R3, 1 minus 3 by 2, which is minus 1 by 2. R1 plus R3, that is 1 by 2 plus 1 by 2. Here is, sorry, this 0 plus 1 by 2 is 1 by 2. So we get elements in this way. After taking 1 by 2 common from each element, in second row elements are 4, 3, minus 1. We take 2 common, 1 by 2 common, so we have to multiply this second row by 2. So minus 4, minus 8, 3, 6, minus 1, minus 2. This is the required inverse. This is unit matrix. So I into A inverse equals to A inverse. In this way we calculate the inverse of given matrix by using elementary transform. The question number 4. We find its determinant first. So determinant of A we calculate here. Here we get the determinant 1, which is not equals to 0. That means this given matrix is non-singular. So we find its inverse. Now see the next step. As given matrix is non-singular, therefore A inverse exists. So we write A into A inverse equals to identity matrix. So substitute the matrix A, identity matrix. Here we require 1. So by multiplying 3 we get 6. 6 minus 5 1. So we apply here elementary transformation. First we multiply this first row by 3. So we get 6, 0, minus 3. In RHS also 3, 0, 0. Now we have to replace this 6 by 1. So for that we have to subtract these two rows. 6 minus 5 is 1. So we require in first row 1. So we write R1 minus R2. So we get 6 minus 5 1, 0 minus 1 minus 1, minus 3 minus 0 minus 3. Here 3 minus 0 3, 0 minus 1 minus 1, 0 minus 0 0. Now we require in place of 5 1. So multiplying by 5 to first row we get here 5. So 5 minus 5 0. We require 5 in a second row. So we write second row first. R2 minus 5 times R1. So 5 minus 5 0. We are changing second row elements. So write first element row as it is, third row element as it is, because here 0 is already exist. So we have to replace this 5 by 0 after applying this elementary transformation. So we get 5 minus 5 0. R2 is 1, 1 minus 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 plus. So 1 plus 5 is 6. R2 is 0, 0 minus here 5 into 3 15, minus minus plus 15. So we get here 15. Same elementary transformation in RHS. We have to write in the second row. So keep first row as it is, this third row element as it is. R2 is 0, R1 is 3. So 0 minus 15 is minus 15. R2 is 1, minus minus get plus. So 1 plus 5 is 6, 0 plus 0, 0. Now entries in the first column are 1 0 0. Now we have to reduce this 6 to 1. So in place of this 6 we require 1. Then in place of this 6 we require 1. So for that, don't divide this second row by 6, because here in RHS this second row reduces to fraction, so which will be complicated for calculation. So take the help of third row. Here is 1, here is 6. If we multiply this third row by 5, so here 1 into 5 is 5, that is 6 minus 5 is 1. So we have to apply elementary transformation by R2 minus 5 times R3 we get. We have to keep first row as it is, we have to keep third row as it is. So we write first row as it is, third row element as it is. Now R2 minus 5 times R3, 0 minus 0, so we get here 0. Here we are taking this elementary transformation for reducing this 6 to 1. So in place of 6 we write 1. Here 15 minus. Here 15 minus 5 into 3 is 15. 15 minus 15 0. So the elements in second row are 0 1 0. Keep same elementary transformation for RHS. So here R2 is minus 15. R3 is 0. So minus 15 minus 0, that is minus 15. R2 is 6. 6 minus 0, we get 6. 0 minus 5 into 1 is 5. So 0 minus 5 is minus 5. Now here 1 reduce, then we require here 0 and here 0. For that we have to add these two rows. Here we get 0. Here we subtract these two rows. So we get 1 minus 1 0. So the next elementary transformation is simply R1 plus R2. We require 0 here. So we write R3 minus R2. After applying the elementary transformation, simple addition, simple subtraction is here. So you do yourself. Then after applying this elementary transformation, here we required 1. Now we have to divide this third row by 3. So we write by 1 by 3 to R3 we get 0 upon 3 is 0, 0 upon 3 is 0, 3 upon 3 is 1. Divide this third row by 3. 15 by 3 is 5, minus 6 by 3 is minus 2, 6 divided by 3, that is plus 2. Now here 0 is already exist, so we require in place of minus 3 1. So we add this first row with third row after multiplying 3. So the next elementary transformation we take here. See this thing. By R1 plus 3 times R3 we get 1 plus 0, we get 1, 0 plus 0, we get 0. R1 plus 3 times R3, minus 3 plus 3, which is 0. So the same elementary transformation for RHS. Minus 12 after multiplying by 3, 5 into 3, 15. Minus 12 plus 15, which we get 3. R1 is 5, R3 is minus 2. So 5 minus 6, which is minus 1. R1 is minus 5 plus 6, we get 1. Keep the elements in second row, third row as it is. Now this left hand side matrix reduces to identity matrix. So I into A inverse is equals to A inverse. So this is the required inverse of given matrix. हे दोनही क्वेश्चन आपल्याला या ठिकाणी प्रोजेक्टवर घेण्यामागचा उद्देश हाच आहे की स्वतःहून तुम्ही प्रॅक्टिस करायला पाहिजे, कारण की क्वेश्चन 1 मध्ये आपण एलिमेंटरी ट्रान्सफॉर्मेशनवरचे प्रॉब्लेम घेतलेत आणि ते आपण या ठिकाणी बोर्डवर समजून दिलेत. तर या ठिकाणी तुम्हाला स्टेप्स कोणत्या फॉलो करायच्या तेवढं मला समजून द्यायचं होतं. आणि राहिला प्रश्न कॅल्क्युलेशनचा, तर तुम्ही व्हिडिओ पॉज करून त्या कॅल्क्युलेशन स्वतःहून करून पाहू शकता, म्हणजे जेणेकरून तुम्हाला त्याच्या प्रॅक्टिस होतील. तुम्हाला हा व्हिडिओ आवडला असेल तर सबस्क्राईब करायला विसरू नका, जेणेकरून पुढचेही प्रॉब्लेम तुम्हाला सॉल्व फॉर्ममध्ये मिळतील.